Hello everyone, this is Sangeetha, Assistant Professor, ECE Department, SNS College of Engineering. So, in the last video, we discussed about the PIC microcontroller basics. So, today we are going to see the hardware architecture with pipelining and we are going to cover 16C67 microcontroller, PIC microcontroller. So, coming to hardware architecture, so the PIC 16 series like PIC 16C66 and 16C67 is a hardware uses a hardware architecture. Which mainly it is used for robust and efficient hardware architecture. So the central processing unit or program memory, that is there are separate memory for program and data memory. And so program memory, that is ROM or EEPROM, used to store the firmware. The range is 1K to 2K. Data memory, a small amount of data memory is used. It is a volatile memory used for temporary data storage during the operation between 36 to 80 bytes. So it is a RISC architecture. So that is a reduced instruction set computer design means the PIC has a small highly optimized set of instructions. So in the last video itself I have told 35 instruction for the PIC 16 series, making it simpler and faster. So this is the block diagram of PIC 16C67 and it is a member of a PIC 16C66 family, which features a variety of components essential for its operation. So the main EEPROM memory and 8-level stack, RAM and instruction decoder, controller, timing generations, oscillator, status register, FSR register and timer, USART serial communication and ports. So we will see one by one. So the first one is W register, that is working register. The main function of W register is a general purpose register used as an accumulator in arithmetic and logical operations. It is often used to hold one of the operands during these operations. For example, MOVW, that is move literal to W. It loads an 8-bit immediate value into the W register, while MOVWF, that is move W to file register, it moves the content of W register to a specified file register. And the next one is status register. So the status register contains various flags that indicate the status of the CPU and the results of arithmetic and logical operations. So the main register, that is the main flags are carry or borrow bit. It indicates a carry out of the most significant bit during addition or a borrow during subtraction. And DC, that is digit carry or borrow bit. It indicates a carry from the fourth least significant bit during addition or a borrow during subtraction. It is mainly useful for BCD arithmetic. And 0 bit, it is set if the result of an operation is 0. And power down bit, it indicates if the device is in sleep mode. And TO, time out bit, it indicates if a watchdog timer time has occurred. And the next one is file select register, FSR. The main function of FSR is it acts as a pointer to any location within the file register space. It is a 8-bit register, so it allows indirect addressing of the file registers. So the value in the FSR determines which file register is accessed when using the INDF register for indirect accessing. So let us move on INDF. So INDF is mainly used for indirect addressing. So when you read from or write to INDF, you are actually accessing the file register pointed by FSR. So for example, move F INDF comma W. It will move the value from the file register pointed by FSR into W register. Next one is program counter. So the program counter is a 13-bit register that holds the address of the next instruction to be executed. It automatically increments after each instruction fetch. Okay. So the program controller instruction like go to, call, so it generally modify the PC control to control the flow of execution. The next one is 8 level stack. So stack is a portion of RAM. So the stack in PIC 16C67 is used to hold the written addresses for subroutine calls and interrupt handling. It is a 8 level deep hardware stack. So each call instruction pushes the written address onto the stack, and each written or read instruction pops the address from the stack. So the stack is not directly accessible. That is, we cannot read from or write to directly, only through call, return, readfile, etc. So using these commands only we can access the stack. So these are the PIC registers, and these are the main uses of PIC. So next one is a watchdog timer. A watchdog timer is a simple timer circuit that performs a specific operation after a certain period of time if something goes wrong. And pipelining. So pipelining means pipelining is a prefetching of instruction. So it is a technique used to improve the instruction throughput of the microcontroller by overlapping the execution of multiple instructions. In PIC 16C66 series, pipelining is implemented to achieve the efficiency. So there are some stages, that is fetch stage, execute stage. So in fetch stage, the instruction is fetched from the program memory, and in execute stage, the fetched instruction is executed by the CPU. So this overlapping process allows the microcontroller to execute an instruction on every clock cycle, significantly improving performance. So in cycle 1, fetch instruction 1, and cycle 2, fetch instruction 1 and fetch instruction 2. In cycle 3, execute instruction 2 and fetch instruction 3. In cycle 4, execute instruction 3 and fetch instruction 4. So this way, after the first instruction, the microcontroller effectively executes one instruction per cycle, doubling the throughput compared to non-pipeline architecture. Hope this video would be very useful to understand the basics of PIC microcontroller and the architecture of 16C67 series. Thank you.